This scene I have opened is called Terrain Side Cut Example, and it's included with the training. And what it is just a procedural terrain, being able to show the edges around the side, which are not showing in the OpenGL, but you can see in the preview render. And this is using a material technique that I'm going to be showing you. And if we take a look at the render, what we can see is along the sides of the terrain, it is conforming to the altitude and the shape of the terrain itself to create layers. Now, in this scene, it's a little exaggerated, where we have the buckling of the terrain. It's not always necessarily going to be to this extent. There are a lot of different ways to control the way this looks, and exactly which areas will conform to the shape of the terrain. So I just want to do a quick run through of this scene. And this current material is only compatible with a procedural terrain using a custom output, although the technique will also work with standard terrains or baked procedurals, but there is a little extra process that needs to be performed in order to get to that point. So first we're going to take a look at creating this technique with the procedural. If we take a look at the terrain itself, I have one area cut out procedurally with one of the zone tools, and we can't see the edges of the terrain, like I said, within the OpenGL, but they are there when it renders. And I just have a very basic setup with just a terrain fractal and then the custom output of the altitude, and then the area cut out, which can be created by making a zone, or in this case I just did it custom. If we take a look at the material, it is a set to object parametric for the mapping mode. The parametric mode is somewhat important for this, although not entirely required. And for the most part, it is a color function. And now we may not end up with anything this complex. I did go ahead and add some additional functions for highlights and bumps, and we will take a look at some of that. But what we can see is that external dependency for the terrain altitude, and that's being connected to the altitude output of the material function, and then being able to mix together color maps with that. So we're going to start with a new scene and build this from scratch, and take a look at the controls that make this up and how it can be customized. So I'm going to go to File and Close. I'm not going to save my changes. I'm going to go to File, New to create a new scene, and I'm going to add in a procedural terrain, which can be done over on the left. Just going to left click on that. If you're using Xtreme, you'll just need to select the procedural terrain. And we're going to edit the object, and I just did a right click in order to pull up that menu. You can also double click on the object in order to edit it, at least within the standalone version. Use the edit object command within Xtreme. Sometimes double clicking does not open the terrain, so that sometimes does not work. Over on the left we have 0 edges. What this does is multiply the output of the procedural and then flattens it around the edges. We're going to turn that off. And then we're just going to go into the altitude production under the procedural tab, right click, edit the function, and then we're going to make this a little more interesting. Now we can also pull open the function node preview, which is a numeric output of the XYZ, and then the function output observer, which is going to give us a preview of what the terrain looks like. So what I want to do is select this simple fractal, which is added in by default, which is underneath the vector3 seed, which is going to randomize the fractal. That seed can be changed, if we go ahead and close that out, with the randomize button next to the altitude production. Multiply by a constant is used whenever you're using a mapping mode, in this case, object parametric, anytime you have a parametric mode, and that is to make our scales match the scene a little bit better. And if you're opening scenes from previous versions of Vue, these multiply by a constant, or this math node will be automatically added to any imported terrains in order to get them to scale correctly. So we're going to select the simple fractal and change that to a terrain fractal. I'm going to go ahead and increase the largest feature amount. And now anytime the largest feature becomes higher than the metascale, which is a larger scale function, and sort of the grouping of the largest features, then the metascale becomes null. So we need to make sure that the metascale, if we're going to use it, is larger than the largest feature. So now I've got around 34 kilometers for the metascale and about 6.4 kilometers for the largest feature. The vector3 seed is random. So recreating this and getting something identical won't be possible unless you have these values set in, which is -559 on the X, 27 on the Y, and 808 on the Z. Okay, so now just to set this up ahead of time, we're going to right-click and add an output node custom dependency. And now the title for this, I'm just going to put some brackets in. I tend to put brackets in front of any custom output I make so that I know it's mine, because there are going to be other outputs available through different objects. So this way I know that it's one that I've created. And between the brackets, I'm just going to add an F so that I know it's a fractal, and then just type in terrain alt. And then we can connect this to the terrain fractal to the altitude output. Click OK, and OK again. So now we have our terrain, and I'm going to change the ground color, just selecting the ground plane, edit the material, edit the color map, and I'm just right-clicking to pull open those options and change the current color to something a little bit darker, just to separate it from the terrain. And I'm going to go ahead and set this to just a final render mode, just so that we can take a look at what the current terrain looks like and get a quick preview. Okay, so we can see the outer area of the terrain was being cut out, and then the main portion of the terrain. And it is a little bit above the ground plane. In order to see exactly which extent to how far it is going, if we switch over to the for viewport mode, which you can do by double-clicking on the top of the viewport, and that'll switch it over. You can also use the buttons up at the top to toggle between the different viewport modes, and then click in a viewport in order to make it active. The box that we see around the terrain is going to be the full elevation or the altitude of the terrain, and that's important for controlling the altitude and the way we're going to control it with a parametric mode. If we edit the object and let's say we have a terrain with the force extension very high, it will clip out the area that's not being used. Sometimes it'll clip out the terrain itself. Now we have a much higher side portion being shown, and that is going to be used within the calculation for the altitude. So we do want to make sure that we're limiting it to the area that we need and not going beyond it. So we really don't need to make any additional changes at this point. And if you do want to go ahead and load in the scene from this point, it's called terrain side cut _001, and I'll be saving throughout the process in different steps. File sizes should be rather small because we're not using any images at this point, so there's nothing really to save with it or any baked geometry So we should get quite a few versions of the procedural available. I'm going to go ahead and select the terrain and right-click up at the top for the material in the Aspect tab, Edit Material. And then we're going to right-click on the color production and Edit function. So what we can do now is take a look at just a kind of direct control for the altitude. I'm going to load in a color map that has a lot of changes in it, a lot of different variations, and I'm going to use one of my color maps, which I'll also provide. With the training, you can load in by selecting New Collection when that browser is open, and choosing the folder off your hard drive, and that will add in any of the presets that are available. So we're going to select the color map 21 that I've got under my natural collection, and this is from the 300 color maps ASLFX collection. But I will provide this color map since it's going to be the one I'm going to be using, and that way you can have the same results. And just to start, I'm going to connect the numeric output, which right now, which is going to be controlling the color map in values between -1 and 1. And if we open the color map, the left side is -1, and the right side, which is the top, is 1. And it's going to take any numeric information in between there to create the color variation. So what I want to do is take this connection, grab it from this constant node that was created, and connect it to the altitude. For version 9 and up, new selections have been made available to control what type of altitude output this is and how far the numbers extend. Right now I have it set to by object parametric. A standard object, absolute, relative to C, they're going to be more of full object values. We're actually going to get a number relative to the actual height and the Z height of the terrain. I'm going to use the by object parametric, which is going to work really nice for this. If we take a look at the render, we're not really seeing much of that color information being converted to the altitude, so it looks like the range will need to be modified. So if we take a look at this parametric mode, the extension in the function node preview is set to 20 if automatic extension is turned on. It'll automatically show you the full extent. So that means that we're going way beyond the value of -1 to 1, and we need that 20 to represent 1 and the -20 to represent -1. So what we need to do is use the filter or add a new filter to this connection. You could select the link, go over to the left, add a filter. I'm going to select that filter and change it over to a map filter. We're going to set the input range to -20 and our upper value to 20. And then our output range is going to be -1 to 1. And that doesn't appear to be showing up right now. It looks like there's a little bit of an issue with the scale of the terrain. What I'm going to do is go into the terrain editor and take the clipping that we have and the slider all the way on the bottom and just clip out the altitude to match almost as close as we can get to the top of the terrain. And now the minimum we're going to keep where it's at, so that way we have that side area being cut out. I'm going to go ahead and scale this up just a little bit with the scale gizmo, and on the Z-axis just bringing it up because we should be able to see that full color map showing along the altitude. So what I'm going to do to not have to worry about the range of the color map is right now, if we select the color map and edit it, what we're going to see is an upper and a lower clamping mode, and right now it's set to clamp. So anytime we have a range outside of -1 to 1, it's just going to basically continue the color that we have for the top and the bottom within that range. Right now we're basically only seeing the top color. Now, in order for this to work out correctly, if you have any sort of gradient or fading colors, as I do, we need to take and make sure that the top color and the bottom color are identical. So I'm going to select that first color, right-click, copy the color, and then go to the last key point on the left, where it's kind of gray, and paste the color. And now change the clamping mode to repeat. So it's going to start over once we go outside the value. We could also set it to mirror if we wanted to mirror the entire color map rather than just repeating it. And that works for the upper mode and the lower mode, so anything above 1 or below -1. So now with that set up, not even needing a map node, what we can do is take a look at a quick render, and we'll be able to see that color map stretching throughout the altitude. So here we have a direct altitude control, where that color map is just not even being changed at all. It's very linear, going through the terrain. And a preview very similar to we would see in the terrain editor. So the full extent of the color map is being controlled by the way we have this clipped out. So if I extend that clipping range all the way, we should see a different output for the color map. And it looks like it's actually pretty much the same. So it's possible that those numbers are not being taken into account. And that is not really changing at the moment. And that's probably mainly just because of the repeat mode being set up. Before, I did have it working without any issues, without having to use a repeat mode, because the total extent of the terrain should be reflected within that altitude without needing the repeat. But it looks like this is just going to work out all right. We should be able to modify this without any problems. So now what we need to do is set up and basically tell View where the terrain ends and how to use the height information to manipulate our color map to conform to the elevation changes. There really isn't a way to directly do it within the material function without relying on the shape of the terrain itself, which we have as an output within the terrain editor, of course in the procedural as that custom output we created. Without this, View doesn't know really when the terrain ends, because none of that information is fed into the material editor. The altitude becomes a constant. It doesn't really know when the terrain ends, when it starts, which areas are higher than others. So that evaluation, we really have to tell it exactly where those areas are. So we're going to go into the material, and we're going to right-click, add an input node external dependency. The dependent and the dependency, we're going to select the procedural terrain from the list, and then we can choose that terrain alt and our altitude. So now if I connect our color map directly to this terrain altitude, what we're going to see, I'll go ahead and render that. Now we see vertical lines throughout the edges of the terrain, representing where the highest areas are, and that kind of going through into the sides. Because the altitude that is output by the terrain editor is going to be two-dimensional. The 3D information along the Z is not used to create a procedural terrain. The only time that information is used is when you're using planetary terrain for spherical scenes. But otherwise, the Z information is completely null and not used at all. So this becomes a projection onto the X and the Y, with the Z not being used So what we need to do is use this information to manipulate the altitude information. What we're going to do is select this connection to our color map and add in a combiner node. And it looks like a Y, very rigid Y. And by default, it's using the blender. There's a lot of different types of combiner nodes. We're going to stick with the blender because it gives us a lot of different options. I'm going to delete that connection to the external dependency at the moment. And for input 0 on the blender, we're going to connect that to the altitude that we had set before. And input 1, which is the second connection, is going to be set to the external dependency. Now, with the combination mode set to blend, our options are 0 and 1 for the ratio. 1 is input 1, 0 is input 0. So we can blend them together, which is sort of an overlay of the information. We'll take a look at that, but what we really want to end up doing is subtracting or multiplying these together in order to get the most control. Now with the direct blend, what we're going to see is a reverse output of what I had showed originally for the example scene, and that we have the altitude taking those lines on the side and dipping them in the reverse direction. So we would need to kind of flip that around in order to get it to conform entirely. But if you were looking for this kind of look where it would kind of dip down where the mountains are, then you would want to just keep that dependency the same, either multiplying and not worrying about a subtraction. So that we don't have to modify this at all, what I'm going to do is set this to blend mode to subtract. And now we can adjust the subtraction amount in order to control how much it's going to conform to the terrain. So just subtracting with a ratio of 1. Go ahead and render that out. And now our lines are a lot closer to conforming to the terrain. We do have some areas that are going in a little bit closer and sort of pinching in, and some areas that are extending further beyond. And that's because the terrain itself is only outputting between 0 and 1, and it's not going down to the -1. So we could manipulate with a map filter this connection to the external dependency, or the actual function that is driving and creating the shape of our terrain. And by taking a look in the function node preview, you don't see, or at least very little, small areas are going below 0, not a very large amount. So what we can do is take a look at that range. When it looks like -2 is about as, or -0.2 is as far as it goes. So we're going to add a filter to that link to the external dependency between the combiner node, set this to the map filter, and set our lower value to -0.2, and our upper value to 1, and then our lower value to -1. So now it's going to take that lower value that was -0.2 and make that -1. And if we're not quite going all the way to 1, we can also set the upper value to, say, 0.9. And if you pay attention to this extension, when automatic extension is turned on, if it goes beyond 1, then you know that you're clipping or going outside the bounds of that input. So just pay attention to that. Make sure you don't go outside 1. In this case, if I was to set this to 0.5, we're going to see the extension go to 2, and that is 1 over where we need to be. And you can get some very interesting terrains this way. So it's not something that you're not able to do and still get a good output. You can create very interesting things this way. But if you want to keep it within a set amount of bounds, then you'll want to keep that extension below. So then we would need to raise it up in order to keep that within the range of -1 to 1. So if I did bring this down to 0.5, let's just take a look, because it's going to intensify the output a lot more, so our subtraction becomes even higher. We can see a lot different of an output. So now the the subtraction is very extreme, and the layers are starting from much lower within the terrain. So you could use that as a starting point and then just adjust the ratio in order to flatten it out or get it to conform a little bit more. I'm going to bring that back up to 0.9, and we're going to work within the -1 to 1 range. And then I'll go ahead and do a quick render. And then what we're going to do is take a look at ways we can vary this and add some additional fractals in order to break apart some of the different areas so it looks a little more realistic and it's not just a smooth line throughout. And probably one of the fastest ways, easiest setups to kind of break apart certain areas or add some variation is just to, instead of using a direct number, ratio 1, what we can do is connect this to a fractal. So what I'm going to do is just click over here off of the function to get that red box, add in a fractal node. So we just have a simple fractal right now. And increase the gain a little bit. And the number that we're going to need for the ratio is going to be between 0 and 1. Now this fractal output is producing something that goes below 1. So what it'll start to do is reverse the function. If we want to prevent that, we can clip the ratio 0 to 1. So any input we add to the ratio will automatically be cut and clipped out in order to prevent any strange looking artifacts from showing, or really dark areas that can show up with color information being used at this way. So we just need to adjust the largest feature of this fractal. I've got it set around 5.8. I'll go ahead and render this out. Okay, it doesn't look like too much of a change. So what I want to do is reduce the scale of the fractal. I'm going to set the wavelength to 0.5 on the X and Y and set the Z to 0.1. Because we're mostly going to need that Z information to cut this out. And since our terrain is very squished and we're in a parametric mode, that value, by reducing it even more, is going to already create sort of a layered effect that we can use. So our variations are getting a little more extreme. Let's go ahead and use a different type of fractal for this. With a simple fractal, by default it sets it to a Perlin noise gradient, which is fairly basic, not a lot of variation. Let's go ahead and change this over to a grainy fractal. A lot of information with this. Take the roughness amount and reduce roughness. We'll change that largest feature size. I'm going to remove the metascale, and then we'll just set wavelength 0.5, 0.5, and then 0.1 on the Z. Add a little distortion. We can increase the gain amount, and this should look a little bit better. So now what we've done is created more variation, but too much of this fractal is going below 0 and causing it to straighten out almost entirely to just use that original altitude. So what we can do is add another filter to the connection between the ratio and the blender. And what we're going to do is change that filter to an offset. And then by raising the height of that grainy fractal, because it goes between 1 and -1, so we're going to raise it up so it goes between 0 and 1.8. So some of the higher areas are going to be clipped out. So we could just kind of fine-tune that. Then we're going to start to get a little more of that shape back into the fractal. And it'll start to conform a little bit more again. And you could just kind of tweak that until you get to a point where you like it. Okay, so it's starting to look a little bit better. I do want to modify this ratio control a little bit because we're losing a lot of the detail we had earlier. So what I want to do is, instead of connecting to this ratio, I'm going to keep that subtraction set to 1, and we're going to create a new blender, or a new combiner node set to blender, set it to blend, and we're going to blend just that direct altitude with the other blender setup and combiner node, and connect that to this ratio. What I also want to do is just close this out, click OK, and switch this over to a world parametric mode. We could even switch this over to world standard. And this way, once we go back to edit our function, we can get a realistic number for the largest feature, so that we actually know the size, and it's just not a whole lot of guessing. So it's looking a lot better. I'm going to increase the largest feature amount, increase the roughness a little bit. What I also want to do is, if we want to modify the colors are very straight right now, and they're not varied. We have very quick gradients. Now we could go in and edit the color map to increase the amount of lines, but there's something else we can do to create a nice variation. And what I'm going to do is add in, we can right click to pull up all of our different nodes, add a color node, and select the color brightness variation. Now this has a built-in Grainy Fractal that modifies hue and saturation, lightness, and gives us the ability to modify color. And what I want to do is extract this color, which right now is green, and connect that to our color map that we have created for the previous setup. And now from that color we can modify with this Grainy Fractal. We want to take that connection from the color map and connect it to this color brightness variation. So what I want to do is reduce the color variation amount, because we're getting some strange colors in here, and reduce the saturation a little bit. And then we can adjust our noise scale and how large the variations are going to be, the roughness amount, how much noise variation there is, and this will give us a nice look to that overall color without having to make any major changes to anything. So now it's a lot rougher. It looks a little more like rock. We could go back, make more changes. Let's say instead of having the combination mode set to blend for this second combiner, we could change that to any of the other modes. We could also have an additional subtraction. We could set it to a multiply. You really just want to play around with it and see which way is going to give you the best looking terrain, or whatever it is you're going for. I'm going to change this wavelength to 0.2 on the Z for that Grainy Fractal. So now I have this set to multiply. So we'll just take a look at this, and then we're going to go and pull out bump map or the bump production, and take a look at how we can also use that to modify the highlight. Now with the multiply, we have a lot of twists and turns within that strata, and it's not all that realistic that way. What I would do if I wanted to keep that multiply and just have it twist a little bit more is reduce the gain output. That'll improve the look of it. For now, we could choose an add or a blend. That'll work pretty well. So let's take a look at the bump channel. What we need for a bump channel is numeric information. So what we can do is use the bump before we go to the color brightness variation. And that's going to use those main lines in order to add a bit of bump. I'm also going to increase the metascale on the Grainy Fractal that we have set up to add more variation. So our bump by default is set to 0.2. We should be able to see it showing up. And it does look like I'll need to increase the bump amplitude, or the output of that, because it's not really showing all that much. I can see a little bit in the side over here, but that's really about it. So we'll just increase that depth to 2. And then if I want to add more color lines, what we can do is take this color map, and we're going to, after selecting it, create another color map to create a duplicate. Connect that to the blender, and we're going to mix these two together. So we're going to select that color output going to the color brightness variation, add in a blender. Now this is a color blender, or color combiner set to blender. We're going to blend those two together, and right now they're identical, so it's not going to make that much of a change. So what I want to do is take the connection going into that color map, and we need to offset it. So since we already have an offset, we can select that offset, and then click on the link between, add a filter, and it's going to duplicate that offset. So all we need to do is offset the number in a negative or positive direction in order to have it change. So now when we go to our blender, we can select multiply, which will increase, and it's going to darken it up a bit. We could also add, we could use a minimum or a max in order to get some finer lines. And if you end up needing to increase the brightness overall in the end, you can add a color node, change it to color correction. You can use the brightness, or you can use the gamma. Gamma works pretty well for this. Add that to the color brightness in between, and then you can adjust, pulling that back a little bit in order to lighten it up. So setting it to 0.8. And if you do want the variation from the color to add to the bump, what we can do is add in a blender between the bump output and the color brightness. Now right now we can't connect it. And if you see our color maps, do have an option available. However, those are for the opacity values for the color map through the filter, and they will not give us the information as it would be for grayscale. So what we need to do is right-click, add a math node, go to conversions, and select color to brightness. This is going to convert our color information into a numeric output that we can use to control bump, highlight, or anything like that. So right now we're going to set this to multiply. And we're going to multiply those, or we could subtract. And you can see the preview showing in the output observer, which is also going to reflect on the bump output, which I set to 2, which might be a little high in this case. So we might just need to reduce that. But let's go ahead and keep this on subtract, set to 1, and go to the bump and change that to 0.5. We can also change the altitude. We can see it's set to 10 meters right now. Since our terrain is 256 by 256 meters on the X and Y, let's go ahead and set that to 100 meters so we can see it a little bit better. So it's the bump is definitely showing up a lot more. Because of the mixing mode I used for that additional color map was set to a value that does not bring through the information from both. It kind of cuts one out. We're not seeing as many lines along the side, so what I could do is if we change that blend from the minimum mode, which is just kind of cutting out certain values, we could bring that over to the multiply, and we should see a little more showing up. Maybe modify our offset in order to get more information showing. We're going to raise up our offset instead of reducing it. And then what I also want to do is take that color to brightness conversion that we have and connect that to our highlight output. You could also use a bump, or the bump output for that. But if we just take that highlight, add a filter, change it to brightness and contrast, we're going to increase the contrast, raise up the brightness a bit, because we want values that are really going to be either closer to 1 or 0 or -1 for the highlights. So if we go over to the highlights, because we connected that, we have a variable highlight. We can set up the overall brightness and our size of the highlight, whether it's dull or shiny. And I'm just going to move the camera a little bit and go to the atmosphere editor under the sun tab and just raise up the pitch and adjust the azimuth a bit so that we can see the bump a little bit more. And take a look at that. So it is looking a lot better. Our bump looks like it's going a little too far in. I do like the bump in the areas that are flatter, but the other parts are going in a little bit too much. So instead of modifying it entirely, what I want to do is edit the filter and set it to clamp the upper and lower clamping modes. So just right click, edit filter, and that way we're going to reduce the bump output so that we're not going beyond a certain range, and that should look a little bit better. And I think we're going to stick with that. I'm going to go ahead and save this out. And save this out as number 2. So I haven't been saving in every step. There's only be a couple variations here to go through. But what I want to show next, it's basically kind of finished with that. First thing I want to show is what we can do if we want to only have this material show on the sides, and you already have a material that you want on top. Now this does work pretty well for a material throughout a terrain, but if you did want to cover that up and only have this sort of side strata showing on just the very steep sides that are cut out, what we can do is add another material layer, and I'm going to call this side cut for the material name. And now let's go ahead and add a material. What we're going to do is in the layer list, we're going to add a layer, and then we can select from, let's go to landscapes, and let's just choose our brown sand. We're going to change the alpha boost to 0, and then we're going to go over to the environment tab, and we're going to control this based on slope. Because the cutout areas are going to appear on the harshest point of slope, being 90 degrees, what we can do is have the slope range of this be set to, say, 85, maybe 80 to be sure. There shouldn't be anything less than that. It should show up pretty well. So now we can see the brown sand material on the top, and then the sides showing that strata-like material we just created. So that's a very easy way to assign what you want to be on top of the terrain, and then have that cutout portion be a different material. So before I talked about the procedure for a standard terrain, because we don't have the height information, what we can do, and what I'm going to take is this terrain. If you hold down Alt on the keyboard, and now I'm going to select the gizmo for the movement on the X, and move that over, it's going to create a duplicate of the terrain. So if I edit the object, and I'm going to increase the resolution up to 1024 by 1024 by clicking on the ×2 button. And then we're going to switch this over in the upper left to a standard terrain, so it's no longer a procedural. We're going to see a different material showing. and the lines aren't really going to work the same way. It is still connected to the procedural terrain, so it is going to work at this point. So what we want to do is remove that external dependency for now, since that will not be available with the standard terrain. And I'm just going to render an area. We're going to take a look at the side, and it shouldn't be conforming. It may be modified slightly or twisting, but it's not going to conform to the shape of the terrain. You can see it's just kind of random. It's based on that mix that we have before. So in order to get that to conform to the altitude of the terrain, what we need is that height information. So we need to get that from our standard terrain. Anytime you have standard terrain, what you can do is go over to the picture option, which is the second to last option on the left of the terrain editor, and we have this existing terrain that we can see showing up. So we need to save that existing terrain information out, which we can do by just saving the terrain itself, or exporting it, rather. So we're going to export the terrain, and we want to choose an image format. Let's go ahead and just use, I believe one of the formats cuts the altitude incorrectly, and it might be the TIFF format. So we may need to use either an EXR or a bitmap. I'm going to go ahead and try the EXR. Go ahead and save that out. And for the EXR options, I'm going to use a PIS compression, 32-bit floating point. Make sure that used alpha is checked off. And then go ahead and click OK. OK again, and then we're going to go into the material on the standard terrain now. Now it has been converted to a standard terrain. And we're going to add in a texture map node. And we're going to choose the unscaled projected texture map, which will extend to the bounds of the terrain, and that way it matches. We're going to import or load in that picture. So here's the image, and I'm going to override the gamma to 1. We're going to load that in, and now we can connect that map filter to the grayscale. Because I was clipping out the map before, it should match the output. It doesn't look like it's going below 0 really. It should give us basically the same output for the export as it did previously with the actual number. If we need to fine-tune the map, we can, but that should do it. So now we use the unscaled projected texture map. We also want to set this to a bilinear interpolation type, and that way we don't have any pixelation occurring. Go ahead and render and take a look. And now it's going to start to conform to the shape. Now, because of all the mixing that we have going on, it is difficult to tell exactly how that is working. So I am going to go back to a more simplistic version, just so we can see what that's going to look like. So removing some of these options, getting rid of the blend, and let's take a look at that. Because the mixing was throwing it off a little bit, because it was a little too extreme. It does need to be tweaked a bit, but now we can see that's showing up a lot better. May need to rotate that around. It does not look like it is lined up entirely. It might be because of the offset I have set up. But for the most part, it is conforming to the terrain. So if you have a standard terrain, you can just export that image and use that as the altitude. If you want to convert from a procedural to a standard, same thing, just making sure that you export out that image. If you have a terrain that's been baked into polygons and you can't edit it within the terrain editor, then the best thing to do I'll go ahead and show you, is to switch to the top camera. And you're going to need to render out the terrain from the top and create a custom material. So what we're going to do is just reset the material really quick. Edit the material, and what we're going to do is edit the color map, make it black, add a new layer, hit the X, change this color map to 255 on the RGB to make it white, and then go over to the Environment tab and the altitude range, -1 to 1, and then fuzziness for the top set to 100%. And this should give us an altitude output. Oh, we do need to also go back into the material and ignore atmospherics and ignore lighting, 2 buttons within the material editor. And we need to do that on both materials. And it looks like maybe the fuzziness should be assigned somewhere else, making sure that we do have it set to object parametric. And we might just need to adjust the gamma in order to get that to show up correctly. But as you can see, the elevation is being converted over to an image. Probably will just need to adjust any gamma settings that you have in order to be able to show that entirely. And then you can save that out, crop it to get your elevation. Now, because the top camera is not any different than any other camera, it does rely on focal lengths, which means it is a perspective camera. So in order to remove any distortion, you will need to move the camera out quite a ways and then zoom in to the terrain. And what that will do is even out the edges and flatten it out. So that way it's going to match the object a lot better. And since we're ignoring the atmosphere and the lighting, we don't need to worry about those affecting the terrain. Because if we have the camera out too far, the atmosphere gets really thick, but that won't affect our image because those settings are ignored within the material. So you can go ahead and open up the version, the example, or the version 2 before I went and modified everything here. If you want to check out the functions, the example version is a lot more complex. Show you how to do a little bit more if you want to kind of reverse engineer it. You can get some pretty cool materials out of it, modifying color maps and things like that, and just kind of altering it to fit your needs. Remembering too that if you use it as a saved material, and I do have a saved version of it, load that in, that you will need to go to the external dependency and set that to the terrain altitude in order to get it to work. So anytime you save out anything with an external dependency, you will need to reload it if it's saved as a preset or an object. So now I just loaded in the preset, assigned the terrain altitude that I had, and then we can see that rendering out. And this is the example version. Like I said, I spent a lot more time on it, kind of fine-tuning things. So definitely take a look at it and see the different ways that things are controlled. Hopefully what I've shown you here will allow you to understand the way the information is being passed through in order to create the material. Some pretty cool stuff you can do with it. So this is the full range of that preset. And you can see there's a lot more layer information available within this version. So a couple of different things from the one we just designed. So just go ahead and kind of check out the different ranges and see what makes it up.